Hello, my name is Parth, and this is my video for the first lab, which is about charge tapes. So the purpose of this lab is to figure out how much excess charge is on a piece of tape. And to do that, we'll first prepare some charge tapes, observe the interaction, and then use that information to get the final measurement. Some assumptions to keep into consideration. So we will ignore air resistance because it's insignificant compared to our much stronger electric and gravitational forces. We will treat each tape as a point charge, which allows us to use a simple formula by assuming that all the charges are in one spot and at the center. We will assume that both tapes have the same amount of charge since they are both made using the same exact procedures, the same materials, and they're also of the same length. Some models. So to visualize the physics of this experiment, we're going to be using GlowScript, which is a VPython model. The goal is to show the two tapes as a point charge and illustrate the electric and gravitational forces at play. Now, just a brief preview of our main result. The charge on tape A and B was determined to be 7 times 10 to the negative 9th coulombs, and the ratio of the electrons to atoms is 1.094 times 10 to the negative 7. So some fundamental physics principles. We have the force of gravity, the gravitational force, which is the downward pull that the Earth exerts on an object. This force is derived from Newton's second law, where force equals mass times acceleration. Acceleration can be substituted with gravity. Next, we have our electric force. The electric force is a push or pull that charged objects exert on each other. And in this lab, it's the upward repulsive force between the two tapes. The first fraction that we see is Coulomb's constant, which is 9 times 10 to the 9 n meters squared over Coulomb squared. Q is our charge on each tapes, and we'll assume that they're going to be the same in this lab. D is the distance between the centers of the two tapes, and that's going to be in meters. So in the floating tape experiment, this force points straight up and directly opposes the force of gravity. All right, so our setup, first we're going to create a base tape by sticking a 20 centimeter strip of clear tape to a flat surface, and we're going to make sure to fold over one end to create a non-sticky handle. This U tape, we're going to be sticking another 20 centimeter strip on the top of the base tape and smoothing it down, and we're going to quickly pull the U tape off of the base tape to charge it, and we're going to create the setup and suspend it between two supports like books or blocks. We're going to bring that second U tape, which we're going to consider as tape A, underneath our tape B until tape B floats due to the electric force. And we measure the distance between the centers of the two tapes, and we're going to find the specific measurements to the charges of the two tapes. So our system is tape B and tape A. Our surroundings is going to be Earth and the position blocks and everything else. So our experimental condition starts with us. We found the distance between the tapes to be 0.015 meters, the length of the tape to be 0.2 meters, and the width of them to be 0.02 meters. The individual U-tapes mass is 0.002 kg, and the gravity constant is 9.81 meters over second squared. So I'm going to try not to walk through the full details of how we got the calculations, because I'll do that when we get to the GlowScript code. But what's important to keep in mind is our force of gravity, our calculation for Q, which is our point charges, our deficient electrons, the number of atoms, and the ratio of atoms. And we have all that included here. So this is my GlowScript code. The first section here is the constants. We already went through these, but the only thing new here is the atoms area, which was given to us in the lab instructions, and the tape area was just the length times the width of the U-tapes. Now, the next part is we're going to determine the force of gravity. The next section after that is we're going to find the electric force. Now, we know that the electric force and the force of gravity are going to be equivalent because the vertical acceleration is going to be 0. So by rearranging the Coulomb's law, we can find Q to be the square root of electric force times the distance squared divided by our K constant. Next is our deficient electrons, and the electron count can be found from the total charge divided by the absolute value of the charge of the electron, which is this number right here. The number of atoms comes from the tape area divided by the atoms area. So we have these constants right here, which would help us to find that. And the ratio of atoms would be the electron count to the total atom count. And all of these numbers are printed here. Now, what's interesting is that our experimental and computational values are the same. So when we go back to the work that we did to find all of these values, they are the same. And that shows that we were pretty close to what it would be theoretically. So next is our possible sources of error. There could be inaccurate measurements. It was probably difficult to get the precise measurements for the floating distance between the tapes. Small error in this distance makes a big difference in our final calculations. The charge loss, the tapes could have lost some of their charges by touching of our hands or other objects. And an uneven charge, the assumption that the charges would spread perfectly evenly across the tape is probably not true. And the charges were probably clumped up in different spots, which does affect the force. So now to consider, what if electrons had a positive charge and protons had a negative charge? So the labels of positive and negative are just a human invention. As long as like charges repel and opposites attract, the observations would still be identical. And this means that we would be able to perform the exact same calculations. So why is it important to handle the tapes as little as possible? What happens when the charged tapes come into contact with your hands or other objects? It's important to handle these tapes as little as possible because touching them can cause the charges to be transferred away, and that can neutralize the tape and ruin the experiment. All right, thank you for watching.